Welcome back, ladies and gentlemen. So if you're new here, my name is Jamie. I am a senior software engineer. I've been coding for about 20 years now. And we are currently going over the solid principles in programming and software engineering. We are going to be doing the Liskov substitution method. So that would be the L in solid in this video. And without further ado, let me continue. So in our previous video, we created a superhero class and it extended the person class. Now this superhero can fly. Okay, so that was part of the open close principle. But continuing to that point, now we're on this Liskov substitution method. And what it means is it basically means that you should be able to swap any instantiation of a class. And like in this case, we have a new superhero, and it should not affect your other code. So for instance, line 53, where it says superhero fly, it's called the flying function, it shouldn't affect it if I swapped it out with something else. So how do we achieve that? The way we achieve it is we would have to create something known as an interface. So we would say interface, and then let's just say we had a super interface, right? So that's the name of our interface, it's the super interface. And in this super interface, we are stating that we must have a fly function. So any class that uses this implementation of the interface is basically signing a contract saying, hey, this class has to have a fly function and it has to return a string, or else it just doesn't work, right? So now that we have this interface, what we're going to do is we're going to add it here. We're going to say implements the super interface. There it is. Perfect. So now let's just say that we have a superhero. So now this superhero becomes a villain somehow because, I don't know, it just magically became a villain. So how do we do that? We can say class super villain, and then we don't necessarily, well, you know what? Let's just say implements. We don't necessarily have to extend the person. We can say implements the super interface. So now what's happening is it's expecting a fly behavior. So if I have this fly function, it's expecting the fly function, but the fly function has to return a string. So I would say, I am a super villain flying, right? So now that we have our super villain class, and we also have our superhero class, if we wanted to swap out the superhero here for a super villain, we should be able to say new super villain. So now it's a new super villain instead of a superhero. And we do not have to modify this line of code if we don't want to. So now if I hit the run, you're going to notice it says, I am a supervillain flying. So that is the Liskov substitution principle in solid in a nutshell. If you like this kind of content, make sure you hit that subscribe button. Make sure you click on the bell for notifications. I'll be continuing this series and, following the interface segregation next. So make sure you catch me in the next video. Thanks for watching.